Hi, today I just wanted to give you a quick primer on how to draw a simple logic circuit and how to simulate it using Quartus II. To start, I'm going to click on Create New Project. Click on Next. I'm going to use a default directory and just call this Demo 1. The file name or the name of the project cannot contain any spaces or other characters. And I just clicked on Finish to bring up the dialog. Now I'm inside the design and I need to add components to this design. The first thing I'm going to do is to add an actual block diagram. There are a lot of options, lots of different ways I can input information into this. A block diagram just allows me to draw a simple logic diagram and put that in. So up comes a normal schematic interface, and we have lots of tools over here. The tool I'm interested in right now is the symbol tool, and this brings up a library dialog, and I have mega functions, others, and primitives under here. Mega functions are complex digital circuits. Others are things that are specific to this tool. Primitives are our basic ones. We have buffers, logic, pins, things like that. I'm going to start with the inputs. So if I click on pin, we see we can get a bidirectional pin, input pins, or output pins. I'm going to start by placing 2 input pins on here. Suppose I could tell you that the function I am intending to draw right now is an XOR function. So I'm going to take A and B and I'm going to create their XOR. If I go back to here now, we have inputs. Now I want some logic. Well, to create an XOR, the first thing I'm going to have to do is invert both of the inputs because I need both of the inputs and their prime to create the XOR function. Now you see it automatically repeats once I've selected a part and placed it. I get an automatic repeat until I go in here. I can right click and cancel, or I'll show you on the next one that I can go just simply hit escape. I'm going to do 2-level and OR logic. So I need 2 AND gates. If I hit escape, I exit that mode, and then I'll need a 2-input OR gate to complete the function. Simply place that on the diagram. And the last thing I'll need is an output pin. If I go back to pins, I'll select an output and place that at the output. Where else would it go? And then I'll go in here, I'm going to name it XOR. Now the wiring tool inside of here, we can pull it up using the menus, but it also comes up automatically if I simply move the cursor over an unconnected pin. And to draw wires in here, I click where I want it to start and I drag to where I want that wire to end. So if I click and release, I do not get the connections that I want. Also, once I've placed a wire, if I don't like where it ended up, I can go back in and just click on the wire and drag it until it's in a place that I might find aesthetically pleasing. Not that I found that particularly aesthetic, but I'd like to just get through this right now. So highlighting all the pins, and there I have a complete diagram, and I need to save that diagram. So I'm going to save it. I'm going to save it with the same name, Demo 1. There's no need to change it. And now I'm going to see if I did this correctly. So I'm going to compile this. I'll click on Start Compile, and it's going to go through and make sure that I did everything correctly. Once it finishes, I can go back and we can talk about simulating it. Everything was successful. I just had a few warnings, and I'm not worried about that right now because I'm not going to actually put this logic diagram onto a chip or anything. So the next thing I want to do is think about simulating this. To do that, I'm going to have to create a new file, and I need a simulation file. A very simple form of this would be the vector waveform file. So once I click on the vector waveform file, up comes what will be a timing diagram when we get done with it. So if I right click under name, I can go in here and insert a node or a bus, whether or not I know what their names are. I can click on the node finder and tell it to list, and what it will do is list all the inputs and outputs for this circuit. So I'm going to move those across and click OK. Now once I click on OK, we have our inputs and outputs listed. Now right now everything's at 0. The inputs are at 0, the output's going to be 0. We'd like to change these values. I can go in here and I can assign a pin a specific value. That may be fine if I am not going to change that input ever, but I would like to change the inputs just to see what will happen. So I'm going to click on the count down here. Now since I have a 1-bit input, any of these choices are irrelevant. I'm just simply going to count for a microsecond. I'm going to tell it to count in steps of 200 nanoseconds for A. I'm going to go into B and do the same thing. I'll tell it to count, and I'm going to tell it to count at 200 nanoseconds. However, this time I'm going to multiply that by 2. And we'll see, now that I have two waveforms in here, I'm going to zoom to fit the window. You see that doubles the counting period so that I count from 0, 0, 0, 1, 1, 0, and 1, 1, all the combinations that we could have for two inputs. Once our input is set, I'm going to save this file. Again, I'll save it as demo 1, and I can come up here and click on the Start Simulation button. Clicking through that dialog, we see now that the simulator comes through. Our output for 0, 0 is a 0. Our output for 0, 1 is 1. Our output for 1, 0 is 1. And our output for 1, 1 is 0. We have successfully made an XOR function. There are some glitches here, but I am not going to worry about those for this time. We can worry about timing at a future date. Thanks for watching. Have a great day.